In this question, we're asked to determine where the cross slope of the roadway is 3.5%. We need to zoom in a little bit to see this better. And here are our drawings, and in particular, because we know we're looking for cross slopes, we're looking for a cross slope of 3.5%. We're really looking for that transition point. For this curve, we have a super elevation of 4%, and we know we're going to transition from normal crown at 2% to that 4%. We can actually see on this drawing as well where we're going to have that point from between 3 and 4%, both at the beginning of the curve at the PC and at the end of the curve, the PT. So we're approximately going to be in these locations, and we can, just based on the stationing of the PC, 53 plus 48.44, we know it's going to be slightly past that point. And the PT is stationed 61 plus 19.37. And just from the design plans, we know it's going to be slightly before that point. So we've got somewhat of a reasonableness check as we solve this problem. Another helpful piece of information we were given on the design plans is what distance it takes to change 1% in cross slope. So it's 20.84 feet to have a 1% change in cross slope. And we'll see how this is going to help us solve this problem. So here's our standard profile view of a roadway. We have a simple curve. So we see we have the PC and PT. For this set of design plans, this is from NCDOT. The split of runoff is 1/3, 2/3. So that's how the PC and PT are located. 2/3 of the runoff before the PC and 1/3 after. Similarly, on the PT side, 1/3 before the PT and 2/3 of the runoff after the PT. So we can start plugging in our information into this diagram so we make sure we understand how everything is related so we can locate that 3.5% cross slope that we're asked to solve. PC of 53 plus 48.44, PT of 61 plus 19.37. We have our design super elevation of 4%, that's given, and we can see that on the design plans as well. The super elevation runoff, we were given that 1% change in cross slope is 20.84 feet. To go from adverse crown removed, which is point B, up to point D, which is our full design super elevation, that's going to be a 4% change. So 20.84 feet times 4 is 83.36 feet. We have that on both sides of the curve, so we have super elevation runoff, and those are equal on each side. There's a symmetrical, simple curve. And now we're looking for that 3.5%. This isn't precisely located, but we know it's going to occur slightly past the PC and slightly before the PT. And this just helps us paint that picture so we understand what we're looking for. We're going to use similar triangles to solve this problem. We'll see that come up in just a moment. And having this visual for us is going to be really useful. So I really encourage you on working a problem like this, have a reasonably accurate diagram to work from. We're going to need to know where adverse crown removed is located so we can set up our similar triangle. So we're going to need to know 2/3 of the runoff. So 2/3 of 83.36 feet is 55.57 feet. And that's that distance here, the 2/3 of the runoff on each side of the curve. That will allow us to find our point where we have adverse crown removed. That's station 52 plus 92.87 on the PC side of the curve. And we're going to add the 2/3 of the super elevation runoff on the PT side of the curve to get station 61 plus 75.14. So again, on the PT side, we're adding 2/3 of the runoff. On the PC side, we're subtracting 2/3 of the runoff to get those stations of adverse crown removed. They happen at 2 points on every curve, at the beginning of the curve and the end of the curve. Now we're going to use those similar triangles to determine where the cross slope is 3.5%. So we're going to have this on both sides, starting on the PC side of the curve. We know that we have full design super elevation at 4%. That occurs over a distance of 83.36 feet. That's our super elevation runoff. So we're going to solve our similar triangles here. We're looking for X. That's going to be 72.92 feet. Similarly, well, stopping here on the PC side, we're going to add that distance, the 72.92 feet, to our point of adverse crown removed. And that's going to give us our point where we have 3.5% cross slopes. That solution here is 53 plus 65.79. Now moving to the PT side of the curve, we have our similar triangles. We're going to set up that similar triangle. The X again is going to be the same as it was on the PC side, 72.92 feet. We're going to subtract that now because we had our adverse crown removed here, station, and we're going to subtract back to get to our 3.5% cross slope. So 61 plus 75.14 minus 72.92 feet gives us a station of 61 plus 02.22, where we're going to have 3.5% cross slope. So again, the final answer, 3.5% cross slope, happens at 2 points. Station 53 plus 65.79 and station 61 plus 02.22 on the PC side and the PT side of the curve.